find the center of mass of a solid hemisphere, first of all, as usual, we try to see if there is axisymmetry, because the center of mass will be lying on that axisymmetry. So obviously this is axisymmetry if this is a hemisphere. If this is a hemisphere of radius r, so on this axisymmetry the center of mass will be lying. As usual, what we do is, at a distance x, we take a small disk. It is a disk, radius is y and thickness is dx. So at a distance x, we have cut a very small section of thickness dx, which comes out to be a small disk of radius y and dx. And then as usual, we shall be using the formula xcm is equal to integral x dm over integral dm with appropriate limits. So we know density is mass by volume. So rho, that is which stands for density. Density is mass by volume, mass upon 2 by 3 pi r cube. xcm is integral of x dm over integral dm, and the limits they are going from the disk. First disk is over here at x is equal to 0, and final disk is at x is equal to r. So the limits of integral, they go from 0 to r. So that comes out to be x into, this is, we have to find the volume, x into, now it is dm, mass is equal to volume into density. Volume of this what? Differential volume of this is what? That is pi into y square. This is like a cylinder only, which has an area pi y square, into thickness is dx. So that makes what? That makes differential element of volume into density if we make it. So volume into density, that makes dm. So this is differential element of mass pi y square dx. So this is dm into rho, obviously. This is volume into density, that is mass, differential element of mass, upon integral of dm is obviously total mass only. So then is a simple integration. We put the values, that is, now we have y also and we have x also. And there is a relationship between y and x, that is, at any time, if we take this triangle, so this is always going to be r, this is y, this is x, so x square plus y square is always going to be r square, whether it is this or even if it is like this. So this square plus this square is always going to be r square. Pythagoras theorem. So from here we say that is y square is equal to r square minus x square. So now we put this expression only in terms of x only, we have put it in terms of x, and x is going from 0 to r. In this step we have taken the density out, it is mass by volume, rest is over here x pi r square minus x square dx. This comes over here, that is mass and mass, they get cancelled. This can be written as 3 by 2, pi and pi will get cancelled, this pi and this pi they get cancelled. That is this pi and this pi, this goes off, this mass and this mass goes off. So this is 1 by this. So this goes to be 3 by 2 r cube. This is r square minus x square dx. When we can open it, so this becomes r square x dx minus x into x square x cube dx integral. So this comes out with 3 by 2 r cube. So this is r square is constant, can be taken out. So this is x dx is, it is x square by 2, limits they go from 0 to r, and for this minus, this is x cube dx. So we raise the power by 1, that is x4, and the raised power comes in the denominator, that is 4. So x4 by 4, this goes from 0 to r. Now when you solve it, this comes 3r by 8. So from here it is 3r by 8. xcm is at a distance of 3r by 8 for a solid hemisphere.